Today we will discuss functions. What is a function? We have already worked with functions, right? Without main function, there is no program at all in C language, rather, right? So, which you have already worked with, rather. It is a set of instructions. What it basically consists of? It is a set of instructions used to perform a specific task. Okay. So now these functions we can classify into library functions. You have already worked with library functions as well, like the printf, scanf, which you are using, available in stdio.h. You have used math library functions like sqrt, power, and all kind of thing, right? They're all said to be library functions, right? Yes, sir. These are available in stdio.h. These are available in math.h, right? And the user-defined functions now, right? User-defined functions also you have worked with, right? Main, is it a user-defined or a library function? It is a user-defined function only, right? Because the code in the main you are going to write. So it's a user-defined function only, fine. And then other functions like where what we exactly going to discuss. For example, to perform addition of two numbers, I'm having a separate add function instead of the code being written directly inside the main. So I can have the separate functions for searching. Let us say before return the search functions like linear binary in main itself. Instead of that, I now have separate functions rather, right? So I can have it, right? So functions I can classify into two kind. One is library, another one is user defined. Okay. Now again, if I classify the functions from prototype point of view, right? From prototype point of view, function prototype. What do you mean by function prototype first, right? Prototype means what? Model, right? Mock model, right? So here the function prototype basically consists of what? Function prototype consists of return type of the function, yeah, we'll discuss what is return type. Okay, return type, comma, function name, arguments. All together is said to be the function prototype, the function model rather, right? So here, if we classify the functions from user point of view, we have classified it into how many types? User defined and library, fine, that we have already discussed. Now if I classify them using prototype concept, then I can classify into four kind. Okay, no return, no argument, Another one is return no arguments. No return with arguments. Return with arguments, right? We'll of course discuss about all this, right? Return with arguments. So if I'm classifying the functions, okay, using prototype aspect, then I can classify it into four kind, okay? What are they? No return, no argument, return, no argument, no return with arguments, return with arguments, right? You'll see these, four things separately, one after the other, okay? No return, no arguments first, right? It means it returns no value and it takes no arguments rather, right? It takes no arguments and returns no value. Okay. So if you look at the syntax of the same, since it returns no value, okay, I can have the return type as void, okay, void, void. It's not u, it's v, okay, void, and then the function name you can give your own name, okay, function name. Then since there are no arguments, you can leave the parenthesis empty, okay, and then you can have some set of instructions. As I said, function is a set of instructions to perform a specific task, right? So this is how the syntax of no return, no argument you can find, right? Got it? Basically, when you are writing the function, as I said, function prototype consists of return type. Return type, if the function is returning no value, we give the return type as void, okay? And here, next is function name is it, right? That is what exactly we have mentioned here. You can see function prototype consists of what? Return type, function name, arguments, right? So you can see here, no return, no argument syntax will have written. The return type is nothing but void because it is returning no value. And then function name, you can give your own name. It is user defined, so you can give your own name based on the context. The other way around, like what exactly the particular function is carrying out, you can specify the same here, followed by parenthesis, you can see. Right, as I said, when we were discussing the first program, right, because we've done even the first program using the main function itself, right, and main followed by parenthesis, we said, yes or no? So if name followed by parenthesis is being identified as the function, as I said that time itself, right? So similarly, a function name followed by parenthesis is said to be the function, of course, rather, right? Any name followed by parenthesis right, to be a function. And now within this parenthesis, if this function is taking any arguments, I want to mention the arguments, right? If it does not take any argument, you just leave the parenthesis empty, or else you can write inside void also, right? It's a nice no return order. We'll demonstrate with the help of an example. Write a function to find addition of two numbers, right? Okay. Now, I'm writing the function here using no return, no arguments. The function name is add. I'm taking because I'm performing what? I'm performing the addition of two numbers. So the name must specify the functionality, right? It's taking no arguments, so I can simply leave the parenthesis empty here. And here the logic required for performing addition of two numbers. You require three variables. I'm taking ABC here. Then you will be reading, right? PF stands for printf here. You will be reading first the numbers, two numbers, enter two numbers, scanf, percentage D, ampersand A, ampersand B here. Then you say C equal to A plus B. Then you are going to print, okay, the sum of A and B, that is percentage D comma percentage D equal to percentage D, A comma B comma C, okay. You will, then there is a semicolon, of course, right? You will terminate this function, right? So you can see this addition of two numbers which you have done before using simple main function, right? So this logic you were writing before in the main function, you were directly executing it. Now I have written the same in the add function, right? And now I'll be, implementing it using the main function, right? So in order to implement that add function, I need to call it in the main function, right? Because as I said at the beginning, the execution of C program starts from main, terminates from main itself. So in order to get that particular function to be executed, you need to call it in the main function, okay? So here, before I'm calling the add function, I wanted to print one statement here, okay? To just specify the user that the control is in main, and then it is transferring to add and then coming back to again main data, right? I'm in main. Now you are calling the function. See, I'm seeing there are some people that is the same person, maybe I can easily identify who is, playing games, of course, rather, right? But in between that audio sound is getting unmuted. So if you are not interested, you can simply quit the class. Okay. So here in the main function, what you do is now you are calling the add function. How do you call the function? By calling it with its name. How do you call? With its name you are going to call. So after once the function is called, then probably you will be back again into the main. We will probably discuss the mechanism of the function, after writing this. So where do you come back again? You come back in main. So I am saying I am back in main. Okay. Now let us look at the mechanism of the function, right? See, this function main is calling add. So this function is called, yes, this is calling, right? So this is said to be called function. Callee, I can say, right? Callee. And this one is being called there, right? This is called, I can say. This is callee, or you can say caller, who is calling rather, right? So this one is calling, so we're calling it as caller function. And this one is being called, so I'm calling it as a call function. Now what happens when main function get executed? As we know that the first statement which you have probably that get executed. So printf statement you have which is going to display I am in main. So this is going to be printed rather, right? So you can see in console, I am in main will be printed, right? Okay. Next, then you have a statement to call the add function. Since main is calling, we say it is a caller, and now what happens when a caller is calling a call function, the control. See, control is here. Basically, as I said, when you know execute, the control will take the first statement of the main, and then it will terminate from the main itself. So after the first statement has been executed, now control moves on to the next statement. So when the next statement that it encounters with is a call function. It is a function call. So when there is a function call, then what happens? The control will be transferred from this caller to call function. This is the call function. And now control is here, right? So it start executing all this statement. When it start executing, probably ABC, there are three variables to be declared. So for each of them, memory of 2 bytes, each memory will be allocated. Then enter two numbers will be displayed, and you are accepting some values, let us say 10 and 20. So they are placed in ABC, AB, and then you are performing C code A plus B. So this is going to be done, and then sum of percentage D percentage equal to percentage D. Sum of 10, 20 equal to 30 will be displayed. Okay, this is going to be done. This is what is going to be done, right? This is all being done from the card one. That is add. Okay, enter two numbers. You have entered, let us say 10 and 20. Then sum of, you are saying 10, 20 equal to 30. This is all being done through whom? Through the add function. Yes or no? So after then, what happens? Control will be transferred from here back to main. So in the main, if you have any statement after the add function, then that particular statement is going to be executed. So you have a statement here to print what? I am back in main, right? So this is going to be printed. I am back in main. It's going to be printed. Yes or no? So this is how the mechanism is. So if you look at the mechanical function, if I am writing the same here, what is happening? The control will be transferred. Control is transferred from whom? The caller. Who is caller here? Main. To where? Called. Which is called? That is another add here. After the processing get done at the call side, after the processing of call, what happens? The control will be transferred back to, control is transferred back to caller. Yes or no? So this is the mechanism. So that's how when being executed and implemented, you got this result. Yes or no? Now, what is the advantage? You will be asking, what is the advantage? We can rather write the same in the main function. Yes or no? So when you can rather implement the same earlier by using main, that would have been nice, because here there are some extra statements you may require. Yes or no? In main, you are having this extra statement, and then you are defining, then you are calling and all. So you may ask, what is the advantage of having these functions? Yes, there is a good advantage of functions we have. Okay, that is nothing but reusability. Advantage of functions. What is the advantage? The major advantage is nothing but reusability. What do you mean by reusability here? Once I have written the code, compile, test, debug, I can reuse the same without having, to do the same again and again. So you're able to rescue a lot of tasks rather, right? Once coded, compiled, tested, debug, function can be reused again and again without having to do the same. This is one of the important characteristic of programming language, right? Reusability. Other advantages that you get is the memory you are able to save, right? Because what happens here, every time when you call, see in this particular example, I've called this add function only once. Let us say I have to perform in the same program at some other point of time, again addition of two numbers, I want to do, then I'll be calling with the same name without having to write the entire code just by name, right? How do I call that entire function just by name? So if I have to perform this addition of two numbers, let us say about 10 times, how many statements that this particular function is consisting of? 1, 2, 3, 4, 5. So I don't need to write these 5 statements to be repeated for 10 times. I just have to call it with its name. So how many total number of instructions that I probably have to write if I am calling it for about 10 times? 10 plus 5 is going to be 15 times. But if I need that the same without function, then probably how many instructions that I have to write? 50 instructions, because 5 and 10 times, right? 5 into 10 is going to be 50. So it means you are able to reduce the instructions first thing. Right? When you reduce the instructions, if you are using it again and again, that's how exactly reusability works. Reuse means when you are trying to use it again and again. When that reuse particular characteristics come into being, you can see the advantage. What is the advantage? You are able to save lot of instructions the other way around, right? So that is one advantage that you get when you are reusing the function, right? What is happening? You are able to reduce. Yes or no? I hope all of you are writing. Reduce the instructions. Reduce the instructions from writing. Yes or no? See, in this example, as I said, if this particular addition of two numbers I require about 10 times. So instead of writing this entire code for about 10 times, 10 plus 10 into 550 total instruction where I require, probably with the help of functions, I could able to reduce it to 15. It means I am able to reduce 35 instructions or not? Yes. So this is one bigger advantage that I get. Another advantage that I get is the memory saving, right? Memory is being saved. How? I'll tell you. See, what happens when you're calling that particular function, for every function, one memory is going to be allocated, which we say it as an activation record. So an activation record is going to be generated for this particular function as per memory required based on its members being allocated for it, right? So when you're calling it, the same memory is going to be utilized. If I am calling it, let us say 10 times, every time the same memory is going to be used. But if I have written this separately without using functions 10 times, 10 into 50, 50 instructions, and the memory required also is going to be 50. So you can see the memory is also being reduced. Yes or no? Memory is being saved from allocation for every time. Every time you need not to do that, right? From allocation for every time. I hope you understand. Next thing is you are able to reduce the typing effort of the programmer. See, if I have to implement this addition of two numbers for about 10 times without using function, then how many? 50 instructions I need to type. But then here, how many? 10 plus 5 is going to be 15. So it means you are able to reduce the typing effort of the programmer. You are able to reduce the typing effort of the programmer. When you reduce the number of instruction, when you reduce the typing effort of the programmer, thereby the instructions will be reduced, yes or no? Thereby instructions are reduced. When number of instructions are reduced, then what happens? Automatically KLOC, lines of code are going to be reduced. Thereby the cost is going to be reduced, right? Thereby cost is reduced. These are the advantages of functions. I hope it is clear to all of you, the mechanism of the function and advantages of the functions. Now we can probably discuss the remaining types of functions. Fine. So here we have discussed the no written argument. We can demonstrate the same using. Okay. This is to demonstrate what? No written, no argument. Function. Okay. It's just a comment anyway. So don't bother about what is written. It's just a comment which is being ignored by the compiler anyway, rather, right? So here I am writing a function first, right? It's case sensitive, so I need to write all that in lowercase. Void add is a function. So inside this, I'm having the logic to perform addition of two numbers, int a comma b comma c, then printf. Here I'm having a statement to tell the user what to enter, rather, right? Enter two numbers, I'm saying. Then scanf. Inside the double quote, we need to give the format specifiers. Here we are reading two numbers, so %d and %d. Then after double quote, comma, you need to specify the variables into which you want to read these values or accept the values which are read from the keyboard, rather, right? So here you have read these two values in A and B. Then you are going to perform the addition of these two numbers, A plus B, semicolon. Then printf. We are going to print the result here. Sum of A and B, right? %d, comma, %d equal to %d, comma A, comma B, comma C. Okay. Semicolon. Okay. So this particular function is performing addition of two numbers, right? Now I have to implement the same, so I'll have to call this in the main. Okay. I am writing some statements, just to inform you and understand that how the control is moving, from where it is going, and after the function gets executed, where it is coming back and all kind of thing, right? I'm in main initially, okay, because the execution starts from main, right? And now I call the function that is add. With its name we call it. Then after the function has been executed, what happens? Where do you go back? You will be back in main itself, right? So you can demonstrate here with the help of the small example. I hope all of you can see this, right? The larger size only, right? Fine. So you can see here, when you execute this particular function, what happens? The execution starts from main. Yes or no? So first statement in the main function you have, I am in main, so this will be executed, this will be printed. When I execute, you can see. After then, the control will move on to the next statement. The next statement is a function call, that is add. So control moves from main to the add, right? Main is a caller and add is a call. So from caller it goes to the call, and then this particular execution happens, declaring three variables and accepting two values from the user, and then performing the addition of the same and printing the same. All that after happened, then from the call function, the control gets back to again to the main function, this is the caller, right? So after add, if you have any statement, like here one statement is there, I'm back in main, that's going to be printed, and then you'll quit, right? So that's how exactly happens. Just execute and see that is what is going to happen on that. Yeah, there is a small, error we got. What is it? What is this error actually? We have not included our header files actually. So we have to, but then it's a warning. You can simply ignore it. It's asking. You can see, I am in main. Can you see all of you? Those errors are because of printf statements, right? If I include that stdio.h, that printf error will not come. This is just a warning. It's not an error. You can simply ignore it, right? If I include that stdio.h, these warnings I don't get. Anyway, you can see the cursor here, right? I am in main. Can you find this? I am in main. First, this particular statement is executed, then add is executed. So after add when get executed, what is happening? It is asking for two numbers. That is what exactly here you can see. I'm entering two values here, 10 and 20. Then what do you get? You will get the sum of 10, 20 equal to 30. This is going to be printed. And then what happens? After that, control comes back to the caller. So when you comes back to main, then you have one statement to print, that is I am back in main. Can you see this? I am back in main? Yes. I hope this is clear to all of you. Yes. Put this, you don't get that warning also. Hash include stdio.h. And again, you can execute and see. Yeah, I am in main, enter two numbers, 20, 40, and then it gives you sum of 20, 40 equal to 60. I'm back in main, right? So I hope the advantage of functions, you are clear with. The main advantage is reusability, right? When you want to use it again and again, once coded, compile, tested, debug, you can rather any times, any number of times, wherever you want, you can call it. So that's what exactly is happening with the library files. In library files, stdio.h, or you talk about map.h, or all these header files are having pre-processed function which are coded, compiled, tested, debug, and are ready for execution there. So you're just calling with its name, and then it is working for you, like printf, scanf, and sqrt, all that, right? So, and every time need not to be written that entire code, which is already written inside those header files and tested, debug, and they're available in the form of executable where they are ready to run. So that's how the same kind of advantage or feel we can have with our own programs as well, right? For example, many of the programs you have done before, like searching linear search, binary search, you have done. So you can have this linear search as a separate function, and then you can call it in a main as and when you require. Similarly, binary search, sorting, and all other. Like many of the programs you have done before, like prime number generation or perfect number generation, all that you can have as separate function, and you can call them based on your choice in the main whenever you want, rather, right? So that way you can probably reuse the functions, right? Once coded, compiled, tested, debug, without having to do the same again, right? This is the main advantage of what the functions giving us in C programming language, right? So we'll probably see the rest of the other kind as well with examples. I hope this is clear to all of you, right? Now we'll go with no return with arguments. I'll take the same example to demonstrate. So the second one, as I said, no return with arguments. So in this kind, what happens is it takes the arguments, but returns no value, right? So if you look at the syntax of the same, there is syntax. No return, so it is void. Function name you can give of your choice. Arguments, you can have arguments, right? So arguments, you can have any number of arguments based on the requirement. Basically, arguments are nothing but the inputs for your function, rather, right? Okay. We'll demonstrate the same using the same example here. Write a function to add two numbers which are passed as arguments, right? So these argument values are to be passed from the caller function, okay? Well, let us first define the code here. No return, so void. Function name is, let us say, add. Taking two arguments, A and B, because I am performing addition on two numbers, right? So these are the two inputs rather, right? So I have to mention the inputs here. Generally, as I said, the arguments will be the inputs for your functions, right? Now you can take another variable C into which you want to get the result of the same. C equal to A plus B. Okay. C equal to A plus B. Then you can print the same. Okay. Sum of that AB rather, right? Sum of percentage G equal to percentage G A comma B comma C semicolon, right? Now you can see this add function is taking arguments, right? For this argument, the values are coming from the caller function, okay? And then you will have a logic to perform here addition of two numbers, and it is predict the result of the same. Now, if I have to call the same in the main function, because in order to execute any function, they have to be called in the main function, as I said, right? So I need here two arguments to be passed, rather, right? So I'm taking, let us say, two variables x comma y in main function, and I am reading these two values. Here I am saying enter two numbers. percentage D, double quote comma, ampersand x, ampersand y. Now I am calling that function add, okay, by passing x comma y, which I have read just before, right? Now what happens? You have declared two variables x and y. So for these two variables, memory been allocated of 2 bytes each, since they are integers. As I enter two numbers, you said it's going to be displayed on the console here. Enter two numbers. Okay. Then you are accepting two values. Let us say, for example, you have entered 10 and 20. They will be accepted in x and y. Okay. Then you're calling the function. Now, when you're calling the function, what happens? The values which you have read, they will be first passed, right? 10 and 20. This in place of x, now what you have? 10. In place of y, what you have now? 20. So these values, okay, are passed here. Then what happens? The 10 comes and then places in this particular A, and 20 comes and then places into B, right? Now you have another variable which is declared inside the add. So for this, memory will be allocated locally. And then A plus B, when you say that is 10 plus 20 will be placed in C, so that is 30 is going to be placed in C. And then you have some statement to display, that is sum of, in place of this percentage D, A value which is nothing but 10, and in place of this percentage D, B value, that is 20. So sum of 10 and 20 equal to 30 will be displayed. Yes or no? But then this particular statement is coming from whom? It is coming from the called function. Yes or no? So after once the processing get done at the called side, now the last statement is termination. So you come back again to main. If you have some statement after this add, that will be executed. Otherwise, it just simply come out of it, rather, right? So you can see what is happening now when you have arguments. Fine, you need to pass values to those arguments, right? So these variables which were already equipped with some values which were being passed here, these variables are said to be what? Actual variables. Okay. These are said to be actual variables. So these actual variables which are holding some values which are read before calling this particular function, they are being passed to these variables. These variables are said to be what? Formal variables. Okay. These variables are said to be formal variables. So what do you mean by formal variables? The variables which are declared inside the function arguments are said to be the formal variables, and the variables which are passed during the function call are said to be the actual variables, right? So these actual variable values which were accepted before are being passed here to the formal variables, and then the control will be transferred, and then the execution of the particular function will be done, and once it is done, then control will be transferred back to the main. Okay, this is how the execution takes place. I will be writing here now what exactly the formal variables and actual variables definition of the same. You can write it in alliance with me. Okay. So what are formal variables? Variables are arguments, right? I can say are declared, are declared, are declared, or you can say pass the other way around, right? No issue, you can rather say declared. Variables are declared during the function definition. During the function definition. Okay, variables which are declared during the function definition are said to be what? Are said to be formal variables. And what are the actual variables? Variables passed, here I should say passed. Variable passed during the function call, okay? During the function call. So actual variables are generally passed from the caller, right? Caller is going to pass it. And formal variables are declared inside the function will. It is available in the call function. Formal variables available in the call function, whereas actual variables available in the caller or callee rather, right? So let us now try to demonstrate the same here with an example. Okay, I'll first save this program before I go for the next one. This is no return, no argument, right? Dot C. I say this is demonstration of another type of function rather, right? Function, no return, no arguments. Fine. I saved it. Now let us copy the same because only certain changes I have to do it. Copy it and go for the next one. Say create new project. Now I'll paste the same. Okay. See, this is performing what? No return with argument. Okay. With argument, I can say. So what is the difference? I have to pass the arguments here. You can see the function definition will have the arguments, which are nothing but the formal arguments. Generally, the arguments are the inputs required for that particular function we give, right? So since the values are already coming from where? Coming from the main, so you don't need to read it rather, right? They have to be read here inside the caller. I need to declare the variables. Let us declare them as x comma y. Okay, and here you are reading them. Then while calling the function, you need to pass these values, right? X comma y. Okay. So you can see here, if you want this, I am back in main, you can probably have it. You can see the control, of course, available back in main rather, right? Anyway, so you can see here what is happening. The execution starts from main, as I said, right? It will start from main. So first it will accept the values required to pass them as argument during the function call. If you are taking in x and y, they are said to be the actual variables here while you are calling the function you are passing. Since you are calling, since you are going to pass while calling the function, you are calling them as actual variables. And then what happens after the values are passed and the control will be passed to this particular function, the execution at that site, that is call site, will be happen, and then the control will be returned back to the main. So you can say this particular statement will be executed. Okay, so let us execute and see here what is happening. Enter two numbers. So this is from the main, it is asking rather, right? So 10 and 20, these are the two values. And now after I have accepted the values, these are values being passed to the function, that is add, and then add is going to happen. So from where this particular statement I am getting, sum of 10 comma 20 equal that is from the add function. And then I have I'm back in main, right? Because after once the execution of this particular function is done, the control will be transferred back to the caller, and where you have another statement to display I'm back in main, right? So that will be displayed. That's what exactly been displayed here, right? So I hope this is clear. We'll save this, of course, as no return with arguments, right? This is with arguments, not C. Okay. So now let us look at the third one. We have still 5 minutes of time, so we'll try to complete the next one. What is the next one? A return no arguments, right? Return no arguments. So here it takes no arguments, but then returns a value, but returns a value. So if you look at the syntax of the same, it is having return, so we'll have the return type here first, and then you have the function name. Then you do not have arguments, so leave the parenthesis empty, right? Okay, let us try to demonstrate the same using the same example, that is addition of two numbers. Write a function to return addition of two numbers. So you can see here, I am now writing the function add. Since it is returning the addition of two numbers, which is integer, so I am giving the return type as integer here. No arguments, so I am leaving the parenthesis empty here. Then here I am having the logic to perform the addition of these two numbers. First, you read two numbers, so you will say enter two numbers. Enter two numbers. Then we have scanf within double quotes %d, ampersand a, ampersand b. Then c equal to, what are you saying? A plus b. Then you are returning c. C, the return type functions will have a return statement. This return is a keyword actually, right? So I am using this return keyword. Return c, the result which I obtain in c, that I am returning. So what do you generally return from a function is nothing but the output that you generate from that particular function you return. Okay. Now I have to execute this. How do I execute this add function? In order to execute the function, I need to call it in the main. Yes or no? So I have to call it in the main function. So when I call it in the main function, it returns me the result, right? So I'm taking one variable res. So I'll be taking the result in this function, in this variable, right? Add without arguments. So I have to say sum equal to percentage d res. Okay. So in this function, what is happening? I have declared a variable res. So for res, memory is going to be allocated inside the main function locally. Then you have function call. When you have a function call, of course there are argument. Then the values for that argument have to be passed. There are no arguments, so you don't pass anything. But then control will be transferred from the caller to call function. Here you have three variables for which memory is going to be allocated 2 bytes each, and then you have entered two numbers. So that's going to be displayed here in the console saying the entered two numbers. You have accepted, let us say 10 and 20, then what happens? This 10 and 20 are going to be placed in A and B. Then you are saying C equal to A plus B, C value will be 30, and that will be returned here. From here, the value is being written. When it is written, what happens? The value will come back to main and then will be placed in res here. Okay, the value written from the add is going to be stored in res, and the control will be transferred in main. The next statement that you have in the main is going to be displayed, and here you are going to print sum equal to, in place of this percentage, the res value will be printed. So you will get sum equal to 30. Okay, this is how the return type functions will work, right? So generally, the return type is going to be mentioned as the value which you are going to return. What is the value you are returning? You are returning C. What is the type of C? It is integer. So the return type must be integer. If you are returning float, then it must be float like that. Okay. So the return type, okay, specify the value which is being written from the particular function, and then the return value which generally you return from the function is nothing but the output generated from the particular function. I hope this is clear to all of you. You can probably demonstrate the same using our online compiler. I'm here copying this, generating another project, creating a new project here. Now let us try to demonstrate this demonstration of return without arguments, right? That is no argument, return with no argument, right? So I should not have these variables. I should remove this. I'll be having A, B, C here. Okay, I should read these two numbers here. A, B I'm reading here. Okay, then the result which is going to be generated out of it should be returned, not displayed from here, rather it should be returned. So I'm using return statement, return. Okay, the keyword which is being used here basically. Return C, I said. Now I should not have this. I just delete this all. Okay, there is a variable called result. I am having to hold the result which is being generated from the function and return res equal to add of xy. Then I am printing the result sum equal to percentage d. After double quote comma, I will be giving the variable in which the value available. Okay, so I hope this is clear now. See, in this add function, I'm having three variables declared and accepting AB, of which addition I have made, and the result is available in C, which I have returned from this function using return statement. And now what happens? The execution starts from main. You have declared a variable res, and then you have a function call here, right? So from here, you know, from here the control will be transferred to add function. Since there are no argument, there are no values are being passed from the function call, right? So the control will be transferred from here to here, and then what happens? This is all being done, and then the result which is generated out of it will be returned. When it is returned, it is stored in RES, and the same is going to be printed. Well, let us execute this and see. Yeah, the error you must have seen, I mean, we must have to specify the type of the data which we are returning, right? Integer, right? Now let us again execute. Enter two numbers, right? 10 and 20. Now you can see the result, sum equal to 30. I hope this is clear to all of you. Yes, we are left with one more function, demonstration probably that we'll see in the next class.